that great introduction. You seem to have memorized my complete bio there. Very impressed. There's no speech notes here. So, good evening everyone. Hope you're doing well. I'm very thrilled and honoured to be here speaking to you all tonight. CASPA is a great association, and from what you just heard, really kind of resonated with me because CASPA is clearly about community. It's about people coming together, working together, collaborating together to solve common problems, and that is how we run our company. As you just heard, I've been with the company a long time, I've done lots of jobs in it. But through that whole 23 years that I've been with the company, the thing we have focused on has been about partnership. It's been about creating a business model that enables other companies to thrive. It's about creating a community of people who use our technology and innovate around what we do to create a better solution than we could on our own. That has worked really well, and you can see from all of you here tonight, this theme of coming together and collaborating is one that certainly resonates on a global basis. Now, I appreciate the kind of Englishness of tonight's proceedings. As you just heard, I was just in Great Britain. I was there last week where I managed to pick up this cold, which was certainly helped to develop in me by sitting on an aeroplane yesterday for 10 hours. But I figure I don't need to tell any of you about the joys and glamour of international travel, such that it is. What I'm going to speak about tonight is about innovation. It's about how we drive innovation, how we collaborate around innovation to create choice for the people who ultimately buy the products that we create. So let's talk about that. But before we get into that, I thought I'd talk first a little bit about jelly beans. And the reason that I thought we'd talk about jelly beans for a few moments was because in a lot of areas of technology, people are always worried about commoditization. Semiconductor devices are referred as commodities. They don't sell for very much money, so they must be easy to do. They must be a commodity. And of course, that could not be far from the truth. If you are in any way involved in building a chip on a leading-edge process, you know how complex that is. And despite the very small amount of money that you get paid for it, semiconductors are far from being commoditized. So the reason that I think the jelly bean analogy is good is because jelly beans are often referred to as commodities, and the term jelly bean is often used to refer to something that isn't a commodity. But the jelly beans here are made by a local company, not too far from here, a company called Jelly Belly, and they've been around for a very long time. I think like about 150 years or even more than that, which for a company that makes confectionery is quite an impressive feat. And the way they've done that is by introducing choice for their customers. Choice is a big part of what they do. If you go and look on their website or go to their factory, which they do a fantastic tour not far from here, they've developed all sorts of flavors of jelly bean. Beyond just fruit flavors, there's all sorts of special themed jelly beans that you can get from them. There's a Hogwarts theme based on the Harry Potter movie series, and you can get a vomit flavor, you can get earthworm flavor, all these different flavors of jelly beans. And by doing this, they've created differentiation for themselves. That differentiation has stood them apart from others who make what is the quintessential commodity, and has allowed them to thrive as a company. They've innovated, they've created all these different flavors, and they've thrived as a company. They're a really impressive company. If you do have the time, the tour looks fantastic. You go see how the earthworms are introduced to their manufacturing process, and go buy them for yourselves. So I think it provides a great example of how something as cheap, as commoditized as the jelly bean can be, made to stand out from competition through innovating, through providing choice, and ultimately that leads to good business. So coming closer to home, when we think about technologies, within ARM we spend a lot of time thinking about mobile devices. Mobile devices have thrived for many years now. They've been a huge economic driver of the technology sector. And some people today look at mobile phones and say, well, they're commodities, they all look the same. How do you choose one from the other? But actually there is a lot of differentiation and choice and innovation going on in mobile devices. You can get very low cost mobile devices. You can get smartphones now that cost a few tens of dollars. It's quite phenomenal. And you can get very expensive devices. You can pay thousands of dollars for diamond-encrusted smartphones if you want to. There really is innovation going on. There's differentiation out there that creates choice. And that choice could be screen size, it could be, there are even people still making phones with keyboards on them. Do you remember having a phone with a keyboard? I'm guessing many of you had a BlackBerry, and I guess many of you miss that keyboard every day of the week, just like I do. Well, there are people that still make phones like that. There's plenty of choice out there to satisfy the demands of different types of consumer. You get them in different colours, you get them in different price points, all sorts of different devices, and that is creating a very vibrant market that is growing strongly and will grow for many years to come. So in our industry, even though these things look like they're kind of maturing, there's still lots of innovation going on. And that innovation is enabled by what many of you in this room do every day of the week. You're thinking about technology, thinking about how to create a differentiated product, how to provide more value in what you do. And if you take a mobile device apart, you can see that there are many choices, different operating systems, different screen sizes, different modems, different forms of connectivity. There are many different ways in which these devices differentiate themselves from each other. And by the creation of standardized components with standardized interfaces between them, then somebody putting a phone together has got lots of choice about the components that they use, and they can put them together in a very rapid way. And so we can get this innovation happening quickly. And that's a really important thing. Now, the choice that we enjoy today hasn't always been this way. About 100 years ago, if you went to buy a car from Mr. Ford, he would say to you, you can have any colour you like as long as it's black. And obviously Ford did a lot of innovation in manufacturing processes, but they simplified in order to create something that was actually low cost and affordable. Very, very impressive. But your choices were very, very limited. And so, unless you wanted a black one, you were out of luck. Now today, things are very, very different, even in the Ford Motor Company. I have here the list of options just for the type of wheel that you could put on a 2014 Ford Focus. There are 12 different options just for the wheel, let alone anything else in the car, let alone the trim, the in-car entertainment system. It is choice galore right now. Things have moved a long way from Henry Ford's day, and I don't know whether it's wrong in his grave thinking about all of this, whether his company should be simplifying things or not. But the fact is, there's a lot of choice, and that choice comes about because consumers want that. Not everybody wants a car that is painted black. Not everybody wants the same sort of wheel on it. Consumers want choice. The automobile industry grew up with lots of different companies. There was a big expansion of the industry. There were choices, and people had to create differentiation in order to survive. We've seen that similarly with mobile devices. We're going to have to keep doing that, keep innovating, keep providing choice in order to survive and prosper. Now, the expansion of the car industry, the advances in manufacturing were a disruption that has enabled new technologies to come along. That disruption driven by choice has enabled new technologies to be created. Now there are things that we take for granted. The smartphone itself was a very disruptive component. You can look upon it and say, well, it's kind of killed off other industries. Nobody buys film cameras anymore because everything's gone digital, and cameras themselves are a changing market because smartphones have got really good cameras built into them these days. So the market for point-and-shoot cameras has kind of gone away, but the camera industry has evolved itself. Bigger digital SLR cameras have become much more domesticated. They're much easier to use. They're less of a scary proposition for most people. And so that industry has evolved because of a disruption in another industry. And we see the smartphone, whilst it has caused some consolidation, it's drawn technologies into it, it has also created new categories of technology. It's enabled things that rely on the fact that you've got effectively a supercomputer in your pocket with a big screen that's got phenomenally high resolution. You can now use that to control other things. Whether it's a fitness device, like the one shown here, I will be wearing one, tiny small device, you can carry on you the whole time, doesn't need a big screen, because it can talk to a smartphone, and you can see what's going on via your smartphone. Your smartphone can talk to your car, your heating system in your house, your security system. So this disruption, although at first people were worried about the industries it was going to damage, is actually creating new industries on the side, which create tremendous growth opportunities. And as we move to a world where smartphones aren't really expensive devices, where they become much lower cost and accessible to billions more people, then we're going to see new categories of product emerge, I believe, that rely on the fact that you've got this piece of connectivity here, this wonderful thing that can connect to so many other things and create benefit for people in their day-to-day lives. So disruption drives a lot of innovation, and I think we're at a fantastic time in our industry where we will see innovation in a way that we've never seen before. So where's this innovation going to come from? I think it is going to come everywhere. We will see smart devices continue to evolve. We'll see higher and higher performance microprocessors built into the devices that we carry around, running off smaller and smaller batteries. It's really quite phenomenal what's been achieved there. And we'll see the form factors continue to evolve. We'll see price driven down, and that will, as I just said, create an opportunity for pretty much every person on the planet to get access to a smartphone. You know, right now, there are about 7 billion phones in use in the world, but there's only about 2 or so billion of those are smartphones. And that's because, until very recently, most people on the planet, unfortunately, don't come to events like this. They live in places where, subsistence farming is a much bigger deal every day of the week, and therefore cannot afford smartphones. But they can afford basic devices, and communication seems to be fairly innate to humans. And so I think as the prices drop, as we do get to the $20 smartphone with much better connectivity and a screen, it's going to provide access to information, to data, to the internet that we all take for granted. And that is going to come to billions more people, which will in itself drive innovation as a result of that connection. So the mobile internet is going to keep evolving. And from there, we'll see the growth of the Internet of Things, and I'll talk some more about that later. But the fact that you can take a very, very small piece of silicon, you can build upon it a very high performance processor, you can put around it connectivity and sensors, that is going to change the world in which we live. It's going to change it for the better. It's going to create a lot of data, as are all of these mobile devices, and that data needs moving across a network into the cloud where it's processed. And as a result, we will see this upward pressure from data on the infrastructure drive innovation within the network, within the cloud. What you ultimately want is a network that provides infinite bandwidth with zero latency. And we can't have that, unfortunately. I'm sure that's beyond the realms of science. But innovators in the networking space are going to continue to try and drive that, provide more and more bandwidth, lower and lower latency. And as that happens, new and different services will be enabled across this network. And with the continued growth of the cloud, with the continued growth of storage, with storage moving from the cloud into the network itself, we will have a computing environment, a global computing environment that we've never seen before. That in itself is an opportunity, just as the internet was an opportunity to create new businesses, new services. This distributed computing environment that we're going to have will enable us to build services and software platforms that we've just never seen before. I think we're at a really interesting time where in our careers, we're going to see this happen. So let's talk some more about innovation. One of the trends that I think is really exciting around innovation is how the maker community has grown up. We're in a world now where you can get a development board with a processor on it for $20, $30. You can connect it up to your computer, you can write software, all the software development tools are free. You can, for very little money, get access to pretty much as much compute power in the cloud as you could possibly want. And you can write an application to run on your smartphone, again for free, to enable all of these things to talk to each other. Out of that environment, we are going to see more and more innovation happen. Through things like Kickstarter, where you can put up an idea to raise money, you can raise funding to actually fund your idea. You can also get the side effect of Kickstarter, which is finding out whether you had a good idea in the first place. You put a project on Kickstarter and nobody funds it, you probably shouldn't do it. You put a project on Kickstarter and everybody funds it within 5 minutes, you are onto a good idea. And the best news is, taking that, making that a real proposition, taking that to market, has never been easier. You have all of this infrastructure available to you to go prototype it. If you then want to go get it manufactured, there are many companies in China mainly who can help you do that. They can provide you services, support to help you build a prototype, help you build a few units, help you suddenly build thousands of units, source all your components, maybe via Alibaba, and get it to market. And if you want to get it to market, once upon a time, if you built something physical and you wanted to sell it, you'd have to go down to Best Buy, you'd have to convince them to put it on the shelves in the right place, because that was the only channel that you had to market. Nowadays, of course, that's not the case. You can sell through Alibaba, you can sell through Amazon, you can create your own website in an afternoon. You have the ability to get to market and reach an audience in a way that you never had before. So once upon a time, you needed massive scale in order to do anything. In order to do one, you just needed huge scale. Now you basically just need a good idea. And I don't think the human race is short of good ideas or ingenuity. And these conditions that we have right now are very, very favourable for innovation and building new products to the market. So I think we're at a very, very interesting time. It's going to drive demand for semiconductors, certainly for the rest of my life and long beyond that, which is great if you happen to be in the semiconductor industry, as many of you are. Now, as I said earlier, behind a lot of this is connectivity. The fact that we can connect devices together, we get very low cost Wi-Fi, Bluetooth, cellular connection chips. We can integrate them together. That creates this environment where the smartphone becomes the controller for anything. And where the smartphone is something you carry around with you, the same trends of connectivity, data, content can be with you whether you're sitting on your sofa in your house, driving around in your car, in the workplace. These themes can drive lots and lots of different types of device, which is an opportunity in its own right. What we're seeing fundamentally is that computing's changed. Computing used to be something that you did at your desk. You sat down, you used a big old keyboard, it was wired to a terminal, maybe there's a mainframe in the back room if you're old enough, and it was something that you did, it was a seated experience, you did it sat down. Nowadays, that is not the case at all. There are computers anywhere and everywhere, and we're going to see that continue as we get smaller and smaller, lower and lower power devices with more and more performance that can be embedded in literally everything. Computing used to be a big terminal. Now it can be in your pocket, it can be a tablet, it can be in every school on the planet because it's low cost enough, and it can be telling you where the best parking space is at the lowest price as you drive into a city. It can be helping the creation of the food that we're all eating be done in a more effective way, because computing's gone from this big box that's sat on your desk or in a back room to something that is now invisible. It's completely pervasive, and it is invisible, and you just get to benefit from it without having to really understand it or what it does. And as a result, on the basis of that extreme compute power being everywhere, and the ability to write software and applications and spend our time innovating on these new services that build upon this massive infrastructure of compute hardware, we'll see more and more technologies come about. And things appear that we just can't really get our heads around today. If you think about the internet, the internet was created really to provide robust telecoms infrastructure in the event of a nuclear war. Now, fortunately, a nuclear war hasn't happened, and we have services like Amazon and Alibaba and eBay and Google, companies like that have sprung up using this infrastructure that nobody was really thinking about at the time. I think this growth of connectivity and networking, of embedded processing, is going to create a platform where innovation can happen on top, and we will have new services and products like Amazon and Google and Alibaba in the future that today just really aren't obvious. And behind all of that is silicon. A lot of what we all do in this room is about making silicon devices lower and lower cost with higher and higher performance. And whilst we spend a lot of time talking about the leading edge, about 16 nanometer FinFETs and 10 nanometer, where all of these technologies are going, if you do take your phone apart, I don't advise you do this, but if you did take it apart, there's all different types of chips in there, memory chips, mixed signal, analog chips, sensors, and all of these technologies are improving and improving, and we're seeing them used in lots of other places. The chips themselves, and the fact that they are so low cost, because of the scale that the smartphone industry creates, basically provides this palette of building blocks that people can use to build other products. And many of the devices that you see today, many of the fitness devices, for example, the smart watches that we're seeing are built from devices that weren't actually designed to be used to build fitness devices or smart watches in the first place. They've come out of the smartphone industry, but they're now there, they exist. And because of the standardization around interfaces, because of the ease with which you can put a system together, we're seeing all of this innovation. Right now, our team did a bit of analysis, looking at all the chips, or not all, but a lot of the chips that our partners have built. And we reckon there are 3,000 or 4,000 devices already that exist today that can be leveraged into Internet of Things products, into wearable devices. So we don't have to wait until the technology turns up, it's here. We can start experimenting, we can start building products. Then as they become successful, iterate and make them better and better. So this environment allows us to create the products that will start a lot of these trends. Now let's talk about the Internet of Things. We at ARM believe that this is a big trend that's going to provide great opportunity. We're in the business of licensing microprocessors, and we see this as a huge driver for the deployment of microprocessors. Billions and billions of devices, more devices, that are going to be used to help connect up otherwise inert things for the better. It's a term that's not been around for very long. About 2011 was when the term Internet of Things started to become commonplace. People started thinking about what it would mean, but didn't really know exactly how it was going to manifest itself. Back in 2013, we commissioned the intelligence unit at The Economist to go and survey a whole bunch of different businesses, different industries, about what they thought the Internet of Things was going to mean for them. And almost universally, everybody came back saying, yeah, this is going to be really useful to me. It's either going to help me run my business in a more effective way, or it's going to help me learn more about my customers, learn more about how my product's used, and enable me to create new businesses on top. But people don't really know where to start. Most people you talk to say, yeah, I need to understand processors and sensors, I need to understand the infrastructure, how to wire it all up, I need to understand analytics. And most of the companies that are going to benefit from IoT just don't have those skills in-house. So having the skills, having the knowledge, having the expertise to put these systems together was seen as a real big barrier to the deployment of the Internet of Things. So we took that on board, lots of people have taken that on board and are trying to solve these problems. That's been a big driver behind what we've been doing over the last little while. Behind all of this, the embedded market itself is huge. The Internet of Things is a very fragmented category right now. To some people it means wearable devices, for some people it means chips in parking spaces in the road, for some people it means smart cities. It's a very broad space. But underlying it, what we need are many silicon devices, really small, and we need a big ecosystem to make it work. We need operating systems, we need application software, we need software running on servers, and we need the right amount of connectivity in between. And so we need the collaboration of many companies. As I said right at the beginning, ARM, just like CASPA, is all about bringing people together to go focus on technology problems, horizontal technology problems that can then be deployed into many different vertical markets. And so we've been working hard on trying to pull our ecosystem together to solve some of the problems that would otherwise limit the deployment of the Internet of Things. The Internet of Things, I think, is going to have benefit in so many different end markets. It's really worth tackling this problem. Right? It's going to be difficult to create an IoT environment that's as open, as pervasive as the Internet itself. But I think it's worth doing because the benefits can be realized in so many different end markets. Whether it's an industrial application where we're trying to make factories smarter, whether it's in the home where you're trying to monitor when you're away or control the lights on or the heating as you're coming home, deploying a smart city. In all of these areas, there are benefits to be had, but require collaboration and innovation amongst a broader and broader audience. 2 weeks ago, in this building, in this room, we hosted our annual TechCon event. And we've been doing this for 10 years. And TechCon 10 years ago used to have people that came to it who were building chips or writing software to run on chips. That was the kind of ecosystem. Now when we think about smart cities, that ecosystem needs to be much, much broader. We need to involve people who might be legislating about how smart cities are put together, who might be running the analytics, running these big servers that are going to be analysing all of this data, running the services on top, deploying energy systems to cities, deploying transportation systems. The number of people involved in this is just growing and growing. So collaboration is a real key to making IoT a reality. Otherwise, it's going to be actually pretty narrow in its scope. Now, one thing we've been doing recently to try and help the deployment of IoT is the creation of a platform that we call Embed. And in this room a couple of weeks ago, we announced the next generation of Embed, where we were looking at how to simplify connecting a kind of leaf node, the end point of the Internet of Things, if you will, a thing, to a service. As I said a moment ago, doing that's quite hard. You've got to understand lots of different technologies. So we're trying to look for ways in which we can simplify that. And we've come at it from two ends. We've come at it from the device end, and we've come at it from the server end to try and create some software that will run on top of all this great hardware to simplify the connections. The reason we're trying to do that is to drive productivity. We want people to build IoT systems really quickly. We don't want it to be a massive problem where you've got to get some consultants from Accenture or someone like that in to help you do it, or you can't start. We want to make it easy, drive productivity, enable people to do it themselves. The Internet of Things is all about data. Data is the new oil. It's the thing that a lot of people can make a lot of money out of, and hence security is a big issue in the Internet of Things. So we've got to make sure that the data is secured and that it's transported in a secure way. We've got to make sure that connectivity is easy. And you look around IoT right now, everyone's proposing new standards for how this must happen. So our solution has to be flexible, because we don't think it's right to dictate an answer. What we want to create is an infrastructure where these different solutions can be applied. We want devices to be easily managed, and in all of this we want it to be efficient, energy efficient and human cost efficient as well. So what we launched a couple of weeks ago was twofold, what we call Embed OS, and this is a relatively simple, although the engineers tell me it's really complicated, really sophisticated, very small, very lightweight operating system that can run on a device. It's designed to be very energy efficient. It's not sitting there polling the whole time. It wakes up and it's got something to do, and creates an infrastructure where whatever your favorite solution for transport layer security or connectivity can be deployed on top of this small operating system. With that, we can quickly and easily connect to a service. So the other part of Embed is what we call our device server, and this is software that runs up in the cloud. You can run it in your own office if you wanted to. You can run it in the cloud, you can run it on Azure or AWS or wherever you happen to want to go. And it very easily allows you to connect to a device and then build a service on top. So we're not offering a service, we're just offering the infrastructure to connect one end to the other. And hopefully that's going to drive some efficiency and get more and more IoT devices connected. Around that then is an ecosystem. At Arm, we've always believed we can't do everything on our own. We need to work with as many people as we possibly can. And really, anyone who wants to work with us, we are your friend. So we're building an ecosystem of partners who are building the silicon devices, partners who are providing some of the software layers that need to sit on both ends of this, and people are going to help deploy and run and manage these infrastructures. The software needs to run on a silicon device. One of the other things we did last week was launch a new variant of our embedded processor family called the Cortex-M7. And this is an embedded processor that is super scalar and has branch prediction in it. Now, I can remember us building simpler processors than that when we targeted the first smartphones. So it is amazing the benefits of semiconductor manufacturing and how we're able to put more and more transistors for next to no money into a very energy efficient device. We can now have a processor as sophisticated as Cortex-M7 in a tiny speck of sand and embed it anywhere. So we have a broad range of processors, the software runs across it all, and depending on how much performance you need, there's a solution there. But actually a lot of the software we're providing here, we're giving a lot of it away for free. A lot of it's based on open source. If you want to go and run it on another architecture, obviously I advise against that, but you can. And then to the partner ecosystem, as I said, putting this whole thing together requires more work than any one particular company can do. And so we've been looking to build partnerships around system companies who can build end-to-end systems, software developers, silicon partners, and create an environment where people can share information. Part of Embed is an online tools development environment. If you have an Embed compatible development board, you can go to the cloud, you can write software, you can write C or C++ or Java in a web browser, get an executable and drag it onto your device, and there is a library of thousands, of tens of thousands of projects that others have donated to help accelerate innovation in this space. So the overall Embed architecture is about devices, it's about client software, server software, and a community of people who are sharing their work with each other and trying to push the technology forward as fast as possible. Now, one of the partners we've been working with is IBM. IBM have a big project, as I'm sure you'll know, around smarter cities. They want to run big server rooms, because they make big servers and run software on top of that, provide data analytics, but they want to be able to get to the end devices. And partnering with us helps get to those end devices. This IoT device platform, the Embed operating system, helps create the connections so that whether you're, say, running a city full of street lamps and you want to be able to monitor, are they working? Where do I need to go do the maintenance? Shall I, raise the brightness or lower the brightness because no one's actually on the street right now? The connection between the end device and the service that a company like IBM would run is enabled through the work we're doing on the Embed device platform. So partnerships like this are really important to get the true benefit out of the Internet of Things. Because it's all about data, and unless we can move the data from one end to the other, the Internet of Things is actually pretty useless. Everyone talks about big data. What we like to say is that you can't have big data without little data. The little data is what's collected from the parking space, the light bulb, wherever. It needs bringing together, it needs amalgamating, and it needs analyzing. Again, these end-to-end platforms take that little data, turn it into big data, and that's when the data becomes really useful. But you have to worry about how you secure it, and you have to worry about keeping it private to make sure that only the people who actually want to get access to this data actually can. Now, the data is massively valuable, and it can be valuable as a small amount of data at a kind of instantaneous point in time, or it can be valuable in aggregate when analysed, maybe offline. And one of the examples that we like to think about is if you're going shopping to your favourite supermarket, maybe you're going to Safeway, the fact that you walked into a Safeway store becomes valuable to a company like Safeway at that moment in time. It has a time domain to it that makes it valuable there and then. Because at that time, all the historical data that's been aggregated about you and your shopping habits can now be used to provide potentially dedicated advertising, dedicated opportunity for you to access something that otherwise you might not notice in the store. So, for example, if you really like some type of exotic fruit that usually comes into season in, let's say December, because of the side effects of global warming, it happens to be available now, and you walk into the store and the store realizes that you just walked in, you happen to like this because you buy it a lot on a regular basis. It can maybe push an advert to your mobile device there and then, notifying you that there is an opportunity for you to go spend some money with them. Now that could be incredibly useful to you. You might find understanding what's on the stores, on the shelves right now, very useful. It could provide you information to help you get lower car insurance or all sorts of different devices, this combination of different types of data at different periods in time. But you've also got to make sure that the data is used appropriately by the people who are collecting it. And that's why we worry a lot about data security and privacy. And in order to make these systems as broadly applicable as possible, we worry about fragmentation of the systems as well. So I'll talk about these for a moment now. Now, data privacy and security, to be clear, aren't the same thing. Data privacy is all about controlling who has access to your data. So it might be great that, let's say, Safeway understand how much beer you drink every week, and let's say they have an offer on beer today when you walk in the store, you might want to get a voucher for that. But you probably don't want your employer to know how much beer you drink in a week, or maybe your car insurance company to know how much beer you drink in a week, and you don't want to find there are side effects from your beer consumption habits, which I'm sure none of you in this room have an issue with, but you don't want those side effects to suddenly manifest themselves in ways you didn't think. So it's really important that you can control who has access to the data. With security, you need to make sure that it's actually kept in the place that you thought it was at the same time. And technology should help with this, and technology actually does help with this. But whenever there is some security breach, it always appears that it is the technology that's let us down somehow, and actually usually it's the humans. Now that in itself is a challenge, and we've got to make that better. But just coming back to the privacy thing for a moment, controlling who has access to your data is a really complex area right now. And we're in an environment now where when we sign up for services, most people don't read the T's and C's. You basically say yes, or you say, I won't have this. And let's face it, most people don't even read the terms and conditions, they just check the box and move on. And I came across a story just a couple of days ago where in London, again, back to the English theme, some researchers did an experiment to see just how blindly people accepted services. And for about $200, they built a Wi-Fi hotspot that they set up in different parts of London. And they just went around just seeing who connected to it. And there was no security built into it at all. So they were able to gather tons of data about people's passwords and their emails. And then, just for added entertainment, they thought, oh, let's put up some terms and conditions here. So, we all love free Wi-Fi, but would you give up your firstborn child to get access to it? Well, the researchers actually made that a condition of free Wi-Fi, and a bunch of people said yes. And clearly they hadn't read it. But it really kind of brings home this message that, A, you should read it, but B, you're probably not going to, and so we need a bit more governance and a bit more of a framework around how these services that are going to gather data about us all are actually used and policed. So this is an issue that needs some work. We've been thinking about this. We've been putting some papers together on a framework we believe that people should start thinking about for how data is, how privacy rather is worked through in all of these kind of free data systems. So we've put some papers together. We've been sharing this with anyone who listens to us, frankly, but we presented this to governments in the UK, in Europe, here in the US. We're really looking to build a further partnership. We did some work with AMD on this, but we want to build out more people involved in trying to get some sanity around how data privacy works. Because my concern is, if you get it wrong, then there's going to be an overreaction to that. There's going to be over-regulation. That will stifle innovation. But I think we're kind of on the clock here. We need to get this done sooner rather than later. Otherwise, it might be too late, and that could inhibit the real benefits of the Internet of Things. Security, as I said, seems like it should all be great. We've got lots of technologies to help us secure data. But if you have to make a password so complex that you write it down, that totally blows it out of the water. So again, we need to do further work, not just on the underlying technology that we can build in the chips, but on the software that sits on top of that, and on how passwords particularly are managed and how users really think about making their data secure. Now the other issue is about fragmentation. The internet is this gloriously open thing that anyone can connect into and really connect to any other point on the planet. It's driven an enormous amount of innovation. It's driven an enormous amount of economic growth as a result. And I think the Internet of Things has the same potential. Potential for huge innovation, new ways of using technology, and new economic growth as well. And let's face it, everyone's looking for the next big thing. Well, I think the Internet of Things could be the next big thing. But if we don't get it right around privacy, security, etc., if we don't get it right around the standards for how systems will work together, how data can be shared in a controlled way from one platform to the next, then we're going to end up in a very fragmented world where we don't have any broad Internet of Things. We have this Internet of silos where people just have end-to-end systems. They provide some benefit, but we lose out on the real big benefit of the Internet of Things, which is going to be interoperability of systems, just like we've seen with the Internet. So we're going to work on that. Our work on the embedded device platform is an attempt to create a more open environment, to make connections easy, to make it easier to move a device from being managed from one service to another, to take the data in a controlled way and make it available to whatever service needs it. But we haven't got all the answers here. We're going to need to collaborate. We need to work with you all and everybody else to make sure that we do come up with the right answers to create as broad and open a platform as we possibly can. Now, if we get this right, I think there is a huge, huge potential for us. As the population of the Earth continues to grow, we're going to live in more and more densely populated cities. Moving around them is going to become more and more complex, and we're going to need invisible technology that just helps us go about our day-to-day lives. We're going to need connected cars not crashing into each other. We're going to need connected infrastructure helping us move around, helping us get the most out of our day, helping us manage the energy that we're all going to be using, helping manage the infrastructure that's producing the food that we are all eating. And as the middle class on this planet evolves, the eating habits of everyone gets more and more costly to actually produce. So producing a glass of orange juice takes about 20 gallons of water. You can have a glass of water instead, but more and more people are going to want to drink orange juice. So there's a demand for resources that are going to need to be very, very carefully managed. And in agriculture, in smart cars, in smart cities, these are all great examples where invisible technology, invisible connectivity can help manage the population demands of the future. This creates an enormous opportunity for anyone involved in technology. We really are scratching the surface of what we can produce today, what we can do, the benefits, the services that we provide on top. But I think it's going to be fascinating to see just how this develops. I don't know exactly where it's going to end up, but I am convinced that it's going to create an enormous opportunity for anyone involved in the technology space. So I invite you all to really get involved in this. If you're thinking, oh my God, my next chip's going to cost so much money to build, can I stay in business, should I sell my company? Well, just think about all of these opportunities, whether it's in connectivity, mobile devices, Internet of Things, networking, servers. We are on a tipping point, I think, where all these technologies will just explode, and that's going to create opportunity for everyone. Ultimately, people want choice, whether it's what phone they use, what service they use to manage their security system in their house. People want choice, and this environment that we have where we can innovate on top of these massively powerful embedded devices creates an environment for innovation that we've never seen before. And I invite you all to get involved and help us together create what this future is going to look like. Thanks very much.
That was very impressive. Everything from jelly beans to IoTs. But all that technology and business aside, I think a lot of our members and friends really are hoping to get to know you at a more personal level, right?
Yeah.
Just a quick question. Which one is your most favorite musical group from the UK? Can you tell us a little bit about it?
Favorite musical group in the UK? So I'm from a town in the UK called Basildon, which is not famous for very much, but one of the bands it created in the 80s was Depeche Mode, who you've probably heard of. And I still listen to them in my car on a regular basis, so I'll go with Depeche Mode. There you go, from my hometown.
Next time when Simon's here, promise, no Beatles, Depeche Mode.
Really listen to the String Quartet.
Okay, so one more thing before we let Simon go. We're going to twist arm Li Chu to, got it. Yuping to present a token of appreciation for our speaker.
Thank you.